Hello all, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the lecture series on the physical design of IoT. So as I told you, the physical design of IoT, it does not does not tell only about the creation of products, but also it defines the physical aspects of the entire IoT ecosystem. So the physical design of IoT is mainly constituting about the two major components are there. So the first one is called things. The next one is called the IoT communication protocols. In the previous lecture series itself, we have covered what are all the things of IoT. So things is nothing but it can be any object like smartwatch, smart TV, or even it can be your sensors, your actuators, or whatever it may be. It refers to the things. So when we say about things, things are broadly classified into the sensors, the actuators, or it can also be classified as your smart device. So what do you mean by sensor? Sensor is nothing but it senses the information. What is mean by sensing the information? That is, it is going to capture the physical input from the environment or from the surrounding. Suppose if there is a temperature sensor. So what is the temperature sensor does? It senses the information. It senses the temperature from the human body or wherever it is being placed, and continuously it will be sending those information and will be storing with the use of the storage interface. So the next object is about the actuators. So what does an actuator does? So it actually responses in real time case. The actuators just respond to the input that is being given by the IoT cloud. So the actuators are nothing but they are the response. They act. So they act based upon the certain decision or the instruction given by the IoT cloud. So the next thing is about the functional block diagram or the IoT block diagram of the physical design. So as I told you previously itself, it is about the different block diagrams that has been shown here. So we have different blocks like that is used for interfacing like connectivity. We have processes, audio video interfaces, input output interfaces, memory interfaces, the graphics card, storage interfaces as well. So the next thing is about, we are going to speak about the IoT communication protocols. That is the next major factor in the physical design of IoT. So the next thing in the physical design of IoT is nothing but the IoT communication protocols. So when you take about TCP IP or the OSI layer model, it will be having about the 7 layers. You all remember the 7 layers in your OSI layer model. But when you take IoT, we have 4 layers. Mainly we have 4 layers. So the first one is link layer. Next one is the network layer, transport layer, application layer. So in short, I'll tell you what is the main thing that is happening here in all these layers. So in application layer, the raw data, okay, so the raw data will be there. Raw information or the raw fact will be there. So those raw information, it will be sent to the transport layer. That is, the application is mainly responsible for interfacing with the lower layers, right? That is, the user only will be monitoring the task or monitoring the application over the application layer. So you will be having the raw data. That raw data will be sent to the transport layer for making it as segments. So we are going to make into some sections or some chunks. We call it as segments. And from there, these segments, it will be forwarded to the network layer for forming of packets using any of these addressing schemes like IPv4, IPv6 or 6LoWPAN. And then it will be proceeding further down to the link layer for further processing. That is for forming other frame packet. So In short, I told you what is happening. Now let's see link layer. So the link layer is responsible for how it is going to send the data, through which medium it is going to send the data. So that will be taking place over the link layer. So in link layer, we have different protocols that supports this communication. So it is Ethernet, 80.2.3 Ethernet or 802.16 WiMAX, LRWPAN cellular networks. So you know that based upon the medium, there are different protocols being used. Suppose if the medium or if the range of the networking device is less than 3 feet, we can use Bluetooth protocol or Wi-Fi. So we can use all those protocols. Suppose if it is less than 5 kilometer, then we can go for 2G 3G cellular protocols. So if it is greater than 100 or less than 100 kilometer, we can go for your LoRaWAN. You can use your Sigfox. So all these protocols are responsible for effective communication and seamless user experience. And in the network, the next layer is the network layer. So here we are going to form it as packets. So IP data gram packets will be sent from the source to the destination layer. So the protocols that are responsible for this are IPv4, IPv6 and 6LoWPAN. So what is IPv4? So here we will be using the addressing scheme, that is 2 power 32-bit addressing scheme we will be using in IPv4. So 2 power 32 address spaces we have in IPv4, but now it is not. We need to have more addressing spaces, so that we are in the migration part of IPv6, wherein we are having 2 power 128-bit addressing space. And if it is low power network, you can use 6LoWPAN protocols. The next layer is the transport layer. So in transport layer, you have two protocols, namely TCP and UDP. So you know what is TCP? TCP is nothing but the connection oriented service, and UDP is a connectionless service. The next layer is your application layer. So the application layer, you have protocols like HTTP, CoAP, WebSockets, MQTT, DDS, AMQP. So all these protocols are available in the application layer.